5.4. Perfect. Okay, so our perfect cubes. Again, starts off with GCF, difference of squares, and factoring trinomials. Do we need to go over any of those, or do you guys remember?
I remember, I think.
Remember? Everybody get on those? Again, that's just review. So let's flip it over to the back page where we have sum and difference of cubes. The first thing we need to remember is what our perfect cubes are. So our perfect cubes can be 1, so 1 cubed gives me 1, 2 cubed gives me 8, 3 cubed is 27, 4 cubed 64, 5 cubed is 125, 6 cubed 216, 7 cubed. Say what? 343. 8 cubed. 512. 9 cubed.
729.
729. And 10 cubed is 1,000. Okay, so those are our perfect cubes. And we're going to use those to take the cube roots of these numbers. And our end result will be the number that is cubed to get to that number. So we have the sum of cubes. So the rule for that is we have a cubed plus b cubed. What we're going to do is we're going to take the cube root of both of those. And our end result will give us an a value and a b value. And we're going to plug that into a formula, a plus b times a squared plus or minus ab plus b squared. So that's how we use our sum of cubes. Take the square root of or the cube root of our values. We get an a and a b, and then we plug those values into our formula. So let's look at number 7 to do it for us. So we've got x cubed.
I think we done that one.
Plus 27. We did. Just a quick review. Take the cube root. And that's going to get us in a is equal to x, b is equal to 3, and we plug it right into our equation. So our a is x, b is 3, so x plus 3, and then a squared, x squared minus ab, so 3 times x plus b squared, or 9. So 3 squared is 9. Which one did we not do, or did we do all 4 of those?
9.
9 is it. So let's look at number 9. We have 500 a cubed plus 4. So sometimes we do not have perfect cubes to begin with, right? 500 is not a perfect cube, and neither is 4. So the first thing that we need to do is we need to take out our GCF. So what can we divide both of those numbers by? 4. Okay. So if we take out a 4, that's going to leave me 500 divided by 4. It is 125 a cubed. 4 divided by 4
Is cancel out.
is 1.
Never mind. They're not.
Right. Well, they cancel out 4, but yeah, we get a remainder of 1. So 4 divided by 4 gives you 1. Then 125 is a perfect cube, and so is 1. So then we can apply it to our formula. So first, take the cube root of both. So my a is going to be equal to cube root of 125 is 5. Cube root of a cubed is 8. And my b is going to be 1.
Wait. A equals 5. So you just square root it by 3, basically.
Yep. Cube
Is that
root.
your answer?
So we're going to use these to then plug back into our formula. So our 4 that we took out, our GCF, we're just going to keep that and we're going to throw it in front of the rest of our formula. So we took out that 4, it's going to stay out front. Then we're going to use 5a as my a, so 5a plus b, or plus 1, right, because we have addition. And then we have a squared, so 5a squared would give me 25a squared. Minus ab, so minus 5a times b. Just gives me negative 5a. And then plus b squared, well, b is 1, so plus 1. So 1 squared is 1.
Wait, where did that 25 come from?
25 came from a squared. So when we square a, 5 squared gets you 25.
Oh, yeah.
A. So that's our sum of cubes.
Wait. Oh, okay, yeah.
You want to do
The 5A.
5a. So we took out the 4, and that gave us 125a cubed. We take the cube root of 125, gives us 5. The cube root of a cubed is a. So that's that 5.
So the square root of both of them on when you plug it in for 25.
Yes. Yeah, you're squaring that whole value down there. What a equals. It's a little confusing because they have a, and that's our variable as well. Okay. You guys want to do 10?
Yes.
Okay.
That's the answer.
So this is our answer for that. So number 10. We got 24 c to the 4th plus 375 c. Okay, so again, 24 and 375, neither of those are perfect cubes. So then what we want to do is we want to find our greatest common factor we can take out of both of those. So what's our greatest common factor between 24 and 375? So if we take out,
What is it? We don't know. We're brainstorming right now.
Brainstorming.
Not full.
so let's kind of think of our factors of 24. We got 2, can't divide 5 by 2.
What about 8?
I don't think anything's going to get us a 5. 4, again, not divisible by 2, so not going to be divisible by 8. What about 3?
Wait, 3 can go into 375?
Gives us that 125. So we can take out a 3. What about c to the 4th and c? We can take out
1C.
1c, and then we have a d and a d to the 4th.
You take out 1D.
We can take out a d. And that leaves us with 8c cubed plus 125 d cubed. Now 8 and 125 are both perfect cubes. So now we can use our sum of cubes. So my a in this case, I take the cube root of 8c cubed, would be 2c. And my b, cube root of 125 would be 5d. So then we can plug it into our formula. So I'm going to go ahead and bring down my 3cd and then plug in the rest. So again, a plus b,
2C plus 5D.
2c plus 5d.
And then
So a squared,
2C squared.
so 2c, that whole quantity squared. So what does 2 squared give us? 4c squared minus A times B
10C,
minus 10CD
and then
plus
5. Wait, is it you multiply 5 2 or just the exponent?
both. So 5 squared gets me
10B.
25 D squared.
Oh.
That's squared. You multiply.
So this is why I get them wrong. It's like, so this is why I need a calculator. I can't do it.
Okay, so that's our sum of cubes. So then let's look at our difference of cubes.
And they're like sort of the same thing.
Very, very similar. So our difference of cubes. Our sign in the middle changes. We now have A cubed minus B cubed. Again, when you take the cube root of both of those, this time our formula is going to be A minus B times A squared plus AB plus B squared. So really the only thing that changes is where our negative is at. Our negative's here rather than here. So that's the difference between our sum and our difference of cubes. Same formula, other than we shift where our negative is at. So let's look at, which one have we done? We've done number 11. No, A minus B. So let's go ahead, we'll just start with 11. We've got x cubed minus 1. So again, cube root of x, my A will be x, my B will be 1.
Wait, so square root of 5 3/3.
So cube root of each.
Okay.
So that gives us x, and notice our B is just 1. Our negative here is just telling us that we're going to be using this formula. Okay. So our B is just, so then let's plug it in. We have A minus B. So x minus 1 times A squared or x squared.
2x squared. Wait, am I wrong? Again. X squared, I'm wrong again. See?
It's just AB, so it's just A times B, so x. And then plus B squared, so plus 1. So then pick another one. Which one will it be? 14, we got 2x cubed minus 54y. Again, 2 and 54 are not perfect cubes, but we can turn them into perfect cubes by taking out that GCF. What is our GCF? 5 by 2.
2x. No, you can't do it.
So that gets us x cubed minus 7y cubed. So then what is our A value going to be? What is the cube root of x cubed? X. What is our B value?
9.
3y. So very close. Okay. Then we're going to take those, plug them right into our equation. So A minus B, so x minus 3y, times A squared, so square x, we get x squared, plus A times B, so x times 3y, 3yx or 3xy.
Yeah,
either
so
way.
does that matter which one the variable one?
And then our last b squared, so plus, so 3y, 9y squared.
So
Any questions on sum or difference of cubes? Okay, so now what we do is we have this little project. You guys can get up, walk around if you want, or you can solve it online